Hi everyone, so we will now discuss the solution for the wines problem, and we have also seen what is the recurrence. So given this array, and we want to find out if we sell wines from each corner, what is the maximum profit that we can make. And we also know that price of wines in the ith year becomes I times, right? So price is going to increase. So in the yth year, all the prices will be multiplied with the y. That is something known given in the problem. And we have also derived the recurrence that the maximum profit that we can make by selling all the bottles from I to j is going to be either we can sell out just bottle first. So this would be your array of I into whatever is the price in the current year plus this sub problem. So this is profit of I plus 1 to j. Or you can say, okay, you will sell this array of j first into y plus profit of I comma j minus 1. So clearly in this problem, you can see in the state of dp, there are two variables involved. One is your start and one is your end, right? This problem will be a problem of 2DTP because there are two variables that are getting updated, and we will, while implementing, we will also take one more y that will make things easier for us, and for the next remaining part we will increment y by y plus 1, right? But still it will be a 2DTP problem because we can calculate the value of y by knowing the value of I and j, right? Because if you know the total number of bottles is n equals to 5 and you know 3 bottles are left, let's say I is here, j is here, and there are 3 bottles, right? Then you know that 2 years have been passed, right? Just to make things simple, I will add on one more variable to my code, that is y. And why we are going to use dp? Because if you say this is 0 to 4, right, then we are going to make a call on 0 to 3, and we are going to make a call on 1 to 4. From here you will make a call on 0 to 2, you will also make a call on 1 to 3. From here you will make a call on 1 to 3, and you will make a call on 1 2 to 4 also, right? What I'm doing is that in the state, right, in the function call, the state of I and j is changing, right? Because if you do I minus 1j, you get up these values of I and j, and if you do I plus 1 and j, you get up these values, right? Similarly, if you do I minus 1 and j, sorry, I and j minus 1 here, and if you do I plus 1 and j here, right? So you can see there can be multiple states which are forming overlapping subproblems. So these two are going to form overlapping subproblems, and that is the reason we are going to use dp here, right? Okay, so let's get down into the code and implement this one, right? Okay. So first thing is we need to know about the base case, and second is we should have a recursive case, right? So base case is very easy. Suppose you're selling bottles and you're selling bottles from I to j. So at every point you are going to shrink I and j, because I is going right and j is going left. So it might happen that in the worst case no bottles are left, right? So no bottles are left. That will happen if I overshoots j. Okay, so if I overshoots j, which means I becomes greater than j, your profit will be 0. This would form our base case. So I can say if I is greater than j, let me return 0. And in the recursive case, I have two options. One is to sell the first bottle, which is at the ith position, and the price of that bottle in the current year, so current year I am denoting by y, will be y plus the, okay, so let me make this function as profit, okay, plus the profit from the remaining bottles, that would be wines array I plus 1, j and phi plus 1. Option 2 would be I can sell the jth bottle first into y plus profit from the remaining bottles, that would be I comma j minus 1 and y would be y plus 1. And finally, what I need to return? I need to return the maximum of these two, option 1 and option 2. That is my final profit, right? Okay, so let's try to run this code. And in the beginning, the year is 1, so I can do cout profit of wines. I is 0, j is n minus 1, and the year is y, right? So let's build our code and run it. So I can say okay. So you can see the answer is coming out to be 50 for the case that we have already discussed in the video. And if you use a greedy strategy, that gives you an answer of 49, right? So we will not use greedy, we will use DP, that gives you the optimal answer, that is 50 rupees, right? So this is how easy the code is, but in this case we have just implemented the recursive solution. If you want to implement DP, then you need to make a DP array. Let's say we have an array of 100 cross 100 and it is initialized with 0, right? So here you will send the DP array and here you will accept the DP array. Okay. And here you will see if particular state is already computed, right? So return if I comma j, if dp of ij is known, right? So what we are doing, we are basically computing dp of ij. What is the optimal answer if you have bottles from index I to index j remaining in your array? So if it is already known, so if dp of ij is non-zero, so I will just return it dp of ij, right? So let me build this again. Okay, so we also need to pass the dp array. Right, so we need to pass the dp array in the function call here also, then build our code, right? So build is successful and let's run this now. So it's wines problem.exe. So you can see answer is again 50, and by doing this we have improved our time complexity to n square, right? Because you are filling out a grid, right? So what you are doing, you are basically starting from this index. So there is a grid like this, there is a matrix. So in the beginning you're making a call from 0 comma n minus 1, so which means you're at this cell and you're making certain calls. Let me just draw again. So you are at this particular cell 0 comma n minus 1, right? So you're at this cell, you're making a call here, you're making a call here, and from here you're making a call here, you're making a call here, and so on, right? And there would be cases, if you go beyond this point you will see that I becomes greater than j. For example, in this cell this is 1 comma 0, so I is greater than j, right? So I is 1, j is 0, so here the answer is going to be 0. Similarly the answer is going to be 0 for these kinds of cells. So effectively you will start by selling out the bottle at this index first, right? This will give you more clarity if you have seen the video for the bottom up approach, but in both approaches we are filling out the same matrix, right? So we are filling out the same matrix and finally your answer 50 would be here, right? And it depends upon the answers which are coming from this cell and this cell, and that is further dependent upon answer from this cell and this cell, right? And so on, right? So I hope this implementation part is clear, and this is quite easy to implement the top-down approach, and bottom up is going to be a bit trickier because you need to fill this array diagonally, right? You need diagonal filling in the bottom up approach. So that's all for this video, guys. Thanks a lot. See you guys in the next part.